Hey everybody, it's Mr. Carr again. Today we're going to be talking about 12.9 day 1, inverse trig functions. This will be our beginning of that. So what are inverse trig functions? Okay, so since we talked about the regular trig functions, we can also just start describing some of their inverses. Remember, we use inverse to find an angle measure. If we know two sides of a right triangle, okay, we're able to find the angle measure by using our inverse trig. But as a function, it doesn't quite work as it's not just as easy as our entire function. Remember so one thing to remember is that trig functions are periodic. That's what we have here with our cosine and sine here, and even our tangent. It's all periodic. It's repeating a pattern over and over again. Okay, these functions are not functions as a whole are not one to one. Okay, bring that back. Okay, they're not one to one functions. Okay, they to be a one-to-one function has to pass the horizontal line test. So if you notice, if I cross here, I've crossed multiple times. Same thing with my sine and with my tangent. Okay, so it does not pass the one-to-one function. They're still functions, but they're not one-to-one. But if we restrict the domains of the trig functions, we can make them one-to-one. What I mean by that is, for example, we look at cosine. Cosine, if I restrict the domain from here to here, okay, I'm just looking from 0 to pi, then this graph passes the horizontal line test. So this graph right here has an inverse to it. Same thing with sine. We're going to restrict it, but sine is actually going to restrict from here to here. This part of the curve is one-to-one if I'm only looking at negative pi over 2 to pi over 2. I'm going to do the same thing with tangent. If I ignore all of these and I just focus on this right here, that's going to exist as well from one-to-one, right? These are all going to be one-to-one there. So the idea is this: if we restrict the domain, so in this case, we're going from 0 to pi. Cosine, that means we're looking at only in the first two quadrants. For sine, we're looking from negative pi over 2 to pi over 2. That creates our complete curve. Well, that is the first and fourth quadrants. So negative pi over 2 to positive pi over 2. Same thing happens with tangent. Negative pi over 2 to pi over 2 creates one complete cycle, and it passes the 1-to-1. So tangent, even though it's not on here, tangent is also going to be in our, oh no, it does say tangent, my bad. Sine and tangent are both going to be in the first and fourth quadrants. So what does this mean in terms of our inverse? We are going to find the exact values of our inverse sine of different ratios. So instead of being able to just plug in my calculator, which is a normal thing you can do, we're going to look at it in terms of our periodic function and where it shows up on kind of the unit circle idea. Okay, so we want to find the inverse sine of 1/2. Write the angle measured in degrees and radians. Okay, again, you can technically put this in your calculator, but we're going to find it on our coordinate grid here. First thing is we're going to draw a diagram. Take a look at the sine. It's a positive. So remember, actually, I probably should have said that. Sine and tangent are both positive here, but they're negative down here in the fourth quadrant. Cosine is positive here, but negative in the second quadrant. So that's what when you draw your diagrams for reference, if you're dealing with any positive of sine, cosine, or tangent, you're putting it in the first quadrant. If you're dealing with a negative sine or negative tangent, put it in the fourth quadrant. Negative cosine goes in the second quadrant. Okay, so that's what we're doing right here. We have a positive sine that we're dealing with. So that's going to go in the first quadrant. Okay, so we're going to draw that out. The ratio is positive there. Label the size of the triangle. Recall from a while ago, the sine of theta is the same as taking the y value divided by the r value, like on that circle idea. So if I draw that out, I'm going to have y over r. I have a radius of 2 and a y value of 1. So it looks something like, let's see here, it'll look kind of like this. A y value of 2. So it'll look kind of like this one. Okay, y value of, oh, sorry, I had that backwards. Y value of 1, r value of 2. So I'm actually going to draw it this way. Okay, so that's my y and r there. Now, using your knowledge of reference triangles, you should hopefully recognize if I have a short leg here of 2 and a hypotenuse of, or sorry, a short leg of 1 and a hypotenuse of 2, that is the same as a 30, 60, 90 triangle. So that's my reference here. That means that this angle has to be 30 degrees. Okay, that's the only way that matches up. The opposite side is 1, the hypotenuse is 2, that matches up to my to that part there. So because it's in the first quadrant, we can say the inverse sine of 1/2 is 30 degrees. Or if we do it in radians, that's going to be, if I change it over from 30 to 30 degrees, do my conversion, it's going to be pi over 6 radians. Okay, and that's our basic gist of these. Every time we do our different trig ratios, we got to do the same process. Draw the diagram, label the sides using our like sine of the theta is equal to the y over r in terms of cosine is x over r, and then tangent is going to be y over x. Okay, so inverse sine of negative root 3 over 2. Okay, so since we're dealing with a negative, we're going to go in the fourth quadrant now. Again, we're still doing y over r. So the y value is going to be negative, is root 3, and r is 2. So root 3 for the y will look kind of like this. Okay, so root 3 and 2 right here. So then that's my theta that I'm trying to find. Okay, so again, we actually have a 30, 60, 90 triangle if you recognize that. Hypotenuse of 2, and then I got a leg of root 3, it looks like this. So if I kind of match it up to where it's at, across the across from the root 3 is 60 degrees. So that's what I have here. Okay, theta is going to be 60. Okay, so now there's multiple things I could do with that. Because it's going 60 in that direction, that means the inverse sine of a negative root 3 over 2 is either equal to a negative 60 degrees, or if I go the other way around, that's going to be a positive 300 degrees. Okay, so don't forget about that. It's going to be 60 going this way, but 300 going that way. Okay, that's that positive coterminal idea. Or in terms of radians, so if I go negative 60, that's going to be a negative pi over 3. Okay, or in terms of 300 degrees, that will be, if I convert that real quick, 300 over 180 is going to turn into 5 pi over 3. Okay, I don't like the way I wrote 5, so let's fix that a little bit. So 5 pi over 3. Okay, and again, so that's what we're finding is those angle measures in either degrees or radians. So negative 60 or negative pi over 3, 300 or 5 pi over 3. Cosine. Find the value of inverse cosine of negative root 3 over 2. Since we are negative, cosine is negative in the second quadrant. So that's what we're going to look at on here. Okay, cosine is written as x over r. So that means x is going to be root 3, r is going to be 2. So in the x direction, I have something kind of like this. Okay, I'm going to have root 3, I'm going to have 2 right here. Now, when we look at this, again, same thing is happening over and over again. We have our same reference triangle at 30, 60, 90. Potentially, these can come up with a 45, 45, 90s, but just every example we've done so far is a 30, 60, 90. So again, based on what this angle is here, this has to be a 1, so that makes this 30 degrees for my reference triangle. Okay, so I'm using this right here. So if that's 30 in terms of the actual degree measure that gets there, that is 30 short of 180. So it's 150 degrees. So that means that the inverse sine of negative root 3 over 2 is equal to 150 degrees. And in terms of radians, it's going to be just short of 5. It should be 5 pi over 6. So just real quick, 150 over 180. Yes, 5 pi over 6. Okay. And now let's do a tangent. So this one's a little bit trickier with the way it is, but same concept to start. It's a negative root 3 over 3. So that's going to put us in the fourth quadrant. So I'm going to draw it right about here. So in this case, since tangent is y over x, y is going to be root 3 and x is going to be 3. That tells me that it's a little bit longer in the x direction. So it'll be like this. Okay. Now, normally, when you look at this, we see that root 3 is across the 60 degrees. So it almost would say that that's what I should have here. I should put 60 degrees right here. However, that's only there if this is then attached to it as like the short leg. Okay, so if I put the 60 here, this is supposed to be the short leg. That's not though. 3 is bigger than root 3. So we get a little bit trickier thing going on here. What might help with this is if I try to recognize that root 3 is shorter than the 3, just like this is shorter than this. So if you notice, that's in terms of 1. What if I divide by root 3 here? Root 3 divided by the root 3 is 1. If I do the same thing here, divide that by root 3, I'm going to rewrite that side. 3 divided by root 3 is the same as multiplying by root 3 over root 3. We're going to rationalize it. So I get 3 root 3 over 3. And then I cancel those out. And I get, hey, look at that. That equals root 3. Now I have this reference triangle right here. So that means I know that this is going to be 30 degrees there. Okay, so it's the 1 is across from that is the short side, and then the root 3 is going to be attached to the 30. Okay, so that means that if I do my inverse tangent of negative root 3 over 3, then that is going to come out as, again, it'll be just like before, negative 30 degrees. Or if I do the standard all the way around, that'd be 330 degrees. That's going the positive direction. Or negative pi over 6. Okay, and if I do the positive direction, 330, so it'll be 330 over 180, comes out to 11 pi over 6. Okay, so that is it for our day. Oh, no, sorry, we got one more. For our day 1, we're going to finish with our quadrantal angles. Find the value of arc cosine -1. Write the angle measure in degrees and radians. So the thing to remember about this one is if I'm dealing with a -1, that puts me on an axis. Okay, that's my quadrantal angles. So if it's either on the axis, it can be here, 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 here. So this is going to be, 1, 0, 0, 1, -1, 0, and a 0, -1. So if I think back to what's happening with my cosine, I could kind of use this idea. It's going to be x over r. Okay, so that means that my x value is going to be the same as my radius, but in the negative direction. Okay, so in this case, with my circle like this, cosine is going to put me here at this spot. Okay, for me to get a cosine, when does cosine of theta equal to a -1? It's going to be at this position right there. Okay, so that's the thing to remember about -1s, zeros, and all of that. Okay, so cosine of theta equals -1 at this position on there. So that means my theta is 180 degrees or pi radians. Okay, so again, that's just a matter of double checking where are we at on our circle in that case. So I knew that because if it was a -1, that means x and r have to be the same value, but one of them is negative. Okay, so that means x and r, the length of that, are the same, but the -1 is that. All right, so we can still use that same ratio, and that is going to be it for our day 1. Okay, and that's our basics of finding using our inverse trig to find those angles on that coordinate grid. All right, that's it for today. Take care, everybody. See you in the next one.